I'm Anil Kumar, and in this video, I'll show you techniques of solving inequalities when absolute functions are involved. So we'll work with these three examples in this video. Solve each of the following: absolute x greater than or equal to 3, absolute x minus 2 less than or equal to 5, and x squared minus 1 absolute value being less than or equal to 8. So these are the three examples which we'll take one by one. You should understand that absolute value of x could be defined as x when x is greater than or equal to 0 and minus of x when x is less than 0. So basically what we do is that if we have a line y equals to x, which is kind of like this, in that case the absolute value, since it is always positive, we reflect the negative part and we get a line like this. Do you see that? So this becomes the absolute function, correct? So it is basically treated as a piecewise function, and x, this value, whether it is less than or greater than some value, really depends on the vertex, that corner. Perfect. So wherever the corner is, the right side is positive, left side is negative. You could think like this. So I hope this part is very clear. How to write this as a piecewise function, correct? So if I'm writing absolute x, which I've already written like this, now let's the second one here. Let me show you a different strategy for the second one here, which is translated. That's true. So when we say absolute x minus 2, that means we have moved this function 2 units to the right, correct? So 2 units right means, let me again make this function here. Something like this, where the vertex has come to the position 2. If I substitute 2 here, I get 0. You get the point, correct? Now we'll take up this function in the later half. First let's discuss these two. Okay, so the first one here is kind of drawn. The second one I've drawn here. Now let me further explore and understand absolute x greater than or equal to 3. What does it really mean? So if I take a number line, so here's the concept. If I take a number line, I'm saying absolute x kind of is 0 at 0. We want the value to be greater than 3. Now absolute value greater than 3 really means that from here the distance, if I say 3 here and minus 3 there, then what I'm trying to say here that we should be 3 units away from this function. That means we're looking for something which is kind of in this direction. Do you see that? So the inequality itself shows you the solution. And when this is equal to, we have to also include the point at x equals to plus and minus 3. So, greater than means away, correct? Away. So you get your solution. Do you see how easy it is? Now, general method is to write the function in that form, a piecewise function form, and then solve, right? So I will do that method also, correct? Since many equations cannot be solved so easily, correct? It becomes difficult. So what we do here is that we redefine our function. We say, well, x could be less than 0, or x could be greater than equal to 0. Now if x is less than 0, then absolute value of x, that equation, less than 0 is minus x, becomes minus x is greater than equal to 3. If x is greater than equal to 0, then I replace absolute value of x, the equation is this, which we are trying to solve. When x is greater than equal to 0, I replace absolute value with positive x. Does make sense to you, right? So there you get a solution. We are trying to say here that x is greater than or equals to 3. Now in this case, if I multiply by minus, I get x will be less than or equal to minus 3. So whenever you multiply by negative, inequality sign also changes. Does make sense to you? Now, to write the final solution, we should check whatever we have got with respect to the interval we are talking about. Since minus 3 is less than 0, all this is valid. And since x greater than 3 is greater than 0, all this is valid. And therefore, we get our solution, which could also be written as from minus infinity to minus 3, right? And since we are talking about equal to, we'll include it with a square bracket. Do you understand? Now in this case, it will be from including 3 to infinity. Infinity can never be included. So you see how we get the solution for absolute x greater than or equal to 3. Perfect. Now let's go with logic like this and straight away get the answer for this equation. You can actually pause the video, answer, and then check with my solution. Now we already have this function here shown kind of a graph x minus 2. Now we want this value to be within 5 units. Less than or equal to means within. So that means I have to go like this in this direction 5 units away. So I could go from here 5 units away. So position minus 3 is 5 units away from 2. Do you see this? Similarly, 5 units to this side will be 2 plus 5, which is kind of 7. So let me extend this. So what I see here is that this point 7 is 5 units away. That means we know 7 minus 2 equals to 5, and we can say 2 minus 5 is minus 3 to get that point. Any calculation you do, correct? But what you get a solution here is less than equals to means you're including these points, and your solution is this, which is between minus 3 and 7. Correct? Now let us solve this using our method. Okay, so I'll take more space here to solve this question. So we are considering now two intervals which are divided because of that point here. Anything to the right remains positive. So we are saying that if x is greater than or equals to 2, then what happens? And when x is less than 2, then what happens? Correct? Our equation is absolute value of x minus 2 less than or equals to 5. We are solving this equation in two different intervals. You get my point. Now if x is less than 2, in that case, absolute value is negative value because we flipped this part, correct? So we could write this as negative x plus 2 is less than or equal to 5. Solving, we get bringing x to this side and 5 to the other side. So what we have here is 2 minus 5, which is minus 3, right? So we are saying that x is greater than or equal to minus 3. Now since we are working in that interval, we could write this solution as from minus 3 to 2. Do you see that? And we're not including 2 here. Do you see that interval? Less than 2. So we could go maximum up to 2. Correct? That is to say that we're trying to go from here to this side, but we could go only till 2 since we have a limit here. Correct? So that is the left side solution. Let's redo this on the right side. Now absolute value of x minus 2 remains x minus 2 when you open this up, less than or equal to 5. We say x is less than or equals to 5 plus 2, or x is less than or equals to 7. Now since we are working in interval which is from 2 to infinity, we could come at maximum till 2. So the solution is including 2 to 7. Do you see that? And when you combine both of them, you get minus 3 to 2 and 2 to 7 to include it. That gives you the final result, and the final result is from minus 3 to 7. Do you see that? So that is the solution which we predicted using our knowledge of absolute function, meaning and knowledge. Do you see that? So at times, especially for objective type questions, you could really solve and get to the answer very fast using the concept of absolute functions and its relation with the number line. So I hope that is important. Here we are showing you solutions in different ways. We have shown you solution on a number line, also with this interval notation. Perfect. Now let's take up the third example, which is solve the inequality x squared minus 1 less than equal to 8. So let's sketch this. How to sketch a function, quadratic function, absolute value. So basically, we'll first sketch the inside part, which is x squared minus 1, so which is simple. It's a parabola, kind of like this, right? So this parabola, we are sketching x squared minus 1. Now if I have to do absolute value of x squared minus 1, then what should I do? Well, remember, this is 0 for plus minus 1, so this point is minus 1, here we have plus 1, and if I write 0 here, I do get minus 1 here. Absolute flips everything negative, reflects it on the x-axis, so we get something like this in the center. However, the sides are same. Do you see that? Sides remain same. And therefore, I could redefine this particular function, which is, let me show the definition here itself, that I could write absolute value of x squared minus 1 as two pieces. One piece is same as x squared minus 1, and this happens when x is less than equal to minus 1, this side, right? Or when x is greater than equal to plus 1. In the center, it becomes negative of this value, which is negative of x squared minus 1 when x is between minus 1 and plus 1. Do you see that? So that is how this function is defined. And therefore, to solve this, either we do these three different intervals, right? Or since the equation is same, I could do it in this fashion. Let me show you now here. So I'm considering one interval, which is let us say x squared, which is x less than equal to minus 1, or when x is greater than equal to 1, right? So basically, I'm trying to solve this equation in these two intervals first. Now here you see the function is as such. What is inside? Do you agree with me? So I could write square root of x minus 1 less than equals to 8 as x squared minus 1 less than equal to 8. Perfect. If I solve the same inequality for x greater than minus 1 less than 1, the inequality being absolute value x squared minus 1 less than equals to 8, that will be written as minus of x squared minus 1 less than equal to 8. Do you understand? Since we flipped it, perfect, since we flipped it. Now let's solve these two equations. So for the first one, we could write this as x squared is less than equals to, taking 1 there, 9. Correct? So we are saying x squared is less than equal to 9. So when we square root, we get that x is greater than equal to or less than equals to 3 and minus 3. So it is between minus 3 and 3. So that is the solution we get for this place. However, we are talking about the interval which is on the right side of 1, right? Or on the left side of minus 1. Do you see that? These are the two intervals. The solution which I am trying to get here is from minus 3 to plus 3. Do you see that? Now what is common? the only common solution is kind of here. Do you see that? So, from this result, in the given interval, the value which is acceptable is, and we are including, right, is from -3 to -1 or from 1 to 3. So I hope that is absolutely clear, right? Not all the values, only these where the interval which makes this equation positive, that means this equation positive, works. Do you get the idea, right? On the other hand, if I try to solve this negative, when I multiply, it becomes x squared minus 1 greater than equal to minus 8, right? Or x squared becomes greater than equals to minus 8 plus 1, or x squared becomes greater than equal to minus 7. X squared greater than equal to minus 7 is always true. Perfect? It is always true. So it is also true in between that interval. Do you understand? And therefore, we also get this solution which is from -1 to 1. Both not included. However, since this has been included in the previous case, we'll consider that to be a part of solution. Is it okay? So in this particular case, graphically, that point was 1. So if I'm taking anything which is 8, is it okay? So let's say anything between 8. So we have that solution, which is from -3 to +3. So everything in between becomes a part of solution, and therefore the solution for this equation is from -3 to +3. Correct? For the given question, we get our answer as everything between -3 to +3. Perfect? Now this is a very interesting question where we'll be solving an inequality with two absolute functions. Let me thank all the subscribers for taking keen interest and posting excellent questions. That makes my channel unique. Now, when we talk about absolute functions, we have to treat them as a piecewise function. That is important to understand. We have two absolute functions here. One is x minus 3, the other one is x plus 2. So let us write them as piecewise functions, and then we'll try to solve them. Okay, so let's do this part here. So we have x minus 3 absolute value that basically is equal to combination of two functions, which will be x minus 3 when x is greater than equal to 3, right? And is minus of this value. So let me write negative of these when x is less than 3. Similarly, the other function, which is absolute value of x plus 2, let me write like this, absolute value of x plus 2, that is combination of two functions, which is x plus 2 and minus of these when x is greater than equal to, what makes this 0? Minus 2 makes it 0, right? So that's the point. So x less than 2. So at minus 2, this second function is 0. At 3, the first one is 0. So that is the point, the vertex of this absolute function that divides into two pieces. Now, once we have these pieces, we actually know that we have to work in three different intervals. So now I'll make three different intervals. Now these three intervals, as you can now appreciate, are because of those points. Since x plus 2 is negative of this value when we are talking about x less than minus 2. So one interval here is from minus infinity to minus 2. The other interval is from minus 2 to 3, right? So the other interval is from minus 2 to 3 when this function changes sign. And the last interval we'll consider is from 3 to infinity when both are positive. Correct? We are solving the same equation, which is absolute value of x minus 3 plus absolute value of x plus 2 should be less than 3 square. I am writing this as 9, right? So we have absolute value of x minus 3 plus absolute value of x plus 2 less than 9. So that is the inequality which is being now solved in 3 different intervals. Now I hope it is simpler. You can actually pause the video at this stage, solve, and then look into my suggestions. Okay. The next step is, in this interval, when it is less than minus 2, how will x minus 3 be? Well, that we have to take its negative value, which is negative x plus 3. How about x plus 2? Both we have to take their negative values, which is minus x minus 2, and that should be less than 9. In the next interval, which is from minus 2 to 3, the second function becomes positive. This remains negative. So it will be minus x plus 3 plus x plus 2 less than 9. And here both become positive. So the equation to be solved will be this. Correct? So now we have these 3 different equations to be solved in their respective intervals. Okay? So let's solve them one by one. When I say minus x, it becomes minus of 2x. Plus 3 minus 2 gives me plus 1, which should be less than 9. Now taking this to the right side gives me 2x. Bringing 9 to this side brings me minus 9 plus 1, which is, we can write this as 2x is greater than minus 8, or we say x is greater than minus 8 divided by 2, which is minus 4. Perfect. Now let us see what solution we get. We are talking about an interval here, which is from let's say this is 0. So this is from, let's say, minus 2 to left side. This kind of an interval. In this interval, we get one solution, which is x is greater than minus 4. So let's say this is minus 4 for us. The solution which we get is that it is greater than minus 4. So whatever overlaps is the real solution. So the value which overlaps between this and the interval is basically from minus 4 to minus 2. Do you see that? So from minus 4 to minus 2. Correct? So that is what it is. We will not include minus 2 since we are talking about x is greater than. Is it okay? So x is greater than that. However, the inequality is less than minus 2. Okay, so wherever it is 0 or equal to, those points will not be considered. Correct? So the solution here in this interval becomes from minus 4 to minus 2. So that becomes the solution. Correct? Now let's look into the center interval, which is minus x plus x, which becomes 0. We got 3 plus 2 as 5, and it becomes 5 is less than 9. Now 5 is less than 9 is always true. And therefore the entire interval is true for us. So minus 2 to 3, entire interval is true for us. Now it is important to note that we have to take at least one place greater than equal to. Since we took this, so we'll take this as interval which includes minus 2. So we will include minus 2 in our solution. Is it okay? So here we get minus 4 to minus 2. Here from minus 2, including it to 3. Now here we have to include 3 since when we include 3 it is x minus 3. Is it okay? So when you combine, you get 2x minus 3 plus 2 is minus 1 less than 9. So we get 2x is less than 10, which is 9 plus 1, or x is less than 10 divided by 2, which is 5. Now within this interval, which is greater than equal to 3, and we are saying less than 5, we say the solution will be from 3 to 5, not including 5. Does it make sense to you? Correct? So combining these 3, we actually get our solution. And the solution clearly is from minus 4 to 5. Correct? So we get our solution, which is from, not including minus 4, since this is less than, okay, so minus 4 to 5. So that becomes the solution. You could always check. If I write 5 here, then I get 5 minus 3 is 2, 5 plus 2 is 7, and both sum is 9, so it is equal to 9. We need less than. So that's one boundary. The other one is minus 4 for us. If I write minus 4, so minus 4 minus 3 is minus 7. Absolute value is plus 7. And here it will give me minus 2. Absolute value is 2. So when we add, you get again 9. So that becomes the other boundary. And if I just write 0 here, for x, I get 3 plus 2 is 5, which is also correct. So we can check that this is the right solution. Perfect. So that is how you could actually solve absolute inequality. So what we see in this particular case is that the interval is divided into 3 because of the absolute functions defined as piecewise functions. So you have to solve each piece in each interval and then compile the solution to get the final solution. I hope that helps. Feel free to share your comments and views and keep posting questions. Thanks for watching. If you like and subscribe, that'll be great for me. Thank you.